All right, guys. So let us start with today's lesson. All right, finally. So today will be our last lesson in your Form 5 Chapter 1. Yeah, this is a very, very long chapter. Okay, very long chapter. Okay, so which it takes a very long time to complete. Okay, so today our main target will be completing the last part of your Form 5 Chapter 1. Then by next week, we will start with Chapter 2. So Chapter 2 is much easier compared to Chapter 1. Yeah, and all the subsequent chapter also quite easy. Okay. For me personally, I will feel that the entire Form 5 chemistry, only Chapter 1 is hardest. All the other chapter is okay. All right, they are doable. Okay, so without further ado, so let's start with today's lesson. Okay, so guys, listen carefully. Okay, so the last part of your Form 5 Chapter 1 Redox is called corrosion. So today we will focus on this thing only. Okay, so guys, you must know corrosion can happen on metals. Corrosion only happen on metals. You never heard the plastic is corroded? No. Okay. For chemistry, for SPM, the corrosion only focusing in metal. So first and foremost, everyone, you need to know what do we mean by corrosion. Okay. What do we mean by corrosion? Okay. So corrosion means what? A part of a metal disappear. So a certain part of the metal gone, disappear. Example, this is a piece of metal before corrosion. Let's say it can be anything, magnesium, zinc, whatever metal it is. So after the corrosion process, you can see part of the metal now disappear. Can you see? Initially, it should be like this one. So this part disappeared. This part disappeared. So when part of the metal eats away, when somebody like eat the metals away, then we call it corroded. All good? So all of you must know what do we mean by corrosion. Okay, next one. How are we going to relate corrosion with chemistry? Let's put your eyes on here. In chemistry, corrosion will take place when a metal atom, when you have a metal, the metal loses electron to become a metal ion. So whenever you have a metal, the metal become metal ion, you can say the metal is corroded. You see, any metal converted to metal ion, this is corrosion. Let me give you a few examples. So let's look at here. The first example, magnesium donated electron to become magnesium 2+. So you can see the metal on the left converted to metal ion on the right. So in this case, you can say the magnesium is corroded. Is it okay? Any metal, when they throw electron to become metal ion, they are corroded. As simple as that. Okay, so you can see magnesium atom loses 2 electrons to form magnesium ion. When metal become metal ion, the magnesium is corroded. Okay, one more. Another example is here. Let's say I have a metal called Al, aluminium. Aluminium is a metal. Aluminium throw away 3 electrons to become aluminium ion. So again, how many electrons is not important. I don't care. What I care is this. Aluminium metal converted to aluminium metal ion. When metal become metal ion, the aluminium is corroded. Yeah. So I hope all of you at this particular moment understand what do we mean by corrosion. So everyone let me know in the chat box. So far so good? So far can understand what is corrosion? So corrosion means a metal throw away electron to become metal ion. That's it. Okay. All right. So let's continue a little bit more. Okay. Now I want you all to be very careful with this fella. This fella called iron. Okay. In SPM, the corrosion they will ask us is always corrosion of iron. They won't ask you corrosion of zinc, corrosion of magnesium. Very rare. Very rare. I shouldn't say they won't ask. I shouldn't say that. Yeah. They seldom ask. They always ask you corrosion of iron. So put your eyes on here. Watch out iron. Okay, why iron? You have to be careful. Because when iron, you want to change it to become ion, you are having some trouble. Why? Everyone, iron, what is the formula? Fe. When Fe become ion, so we got a bit headache. We got a bit headache. Why? Iron can be Fe 2 plus or Fe 3 plus. That's the problem. Because if you look at other metal, no problem one. Aluminium must be Al3 plus, confirm. Magnesium must be Mg2 plus, confirm, isn't it? But iron is an issue. Iron can become Fe2 plus and also can become Fe3 plus. So now the question is, which one should we use? Common sense. Can we complete the half equation together? Let's say Fe want to become Fe2 plus. The charge on the left is 0, on the right is 2 plus. You put 2 electron here. Okay. Another one. Fe want to become Fe3 plus. The charge on the left is 0, on the right is 3 plus. So you put 3 electron at here. Is it okay? Okay, from here, what you know? If you want to change Fe to Fe2 plus, you need to donate 2 electron. If you want to convert Fe to Fe3 plus, you need to donate 3 electron. Okay, everyone, I need you all to use your common sense. You think donating 2 electron is easy or donating 3 electron is easy? So you type 2 or 3 in the chat box. Donate 2 electron easier or donate 3 electron is easier? 2, right? Common sense. That's why if iron want to undergo corrosion, iron will become Fe 2 plus. Understand? Because if Fe want to become Fe3 plus, more troublesome. You need to donate 3 electron. You get it? But if you want to become Fe2 plus, donate 2 electron can already. Common sense. Donate 2 electrons should be easier compared to donate 3 electron. So that's why when iron want to undergo corrosion, they will donate 2 electron to become Fe2 plus. That's why in SPM you won't see this. Fe become Fe3 plus. You won't see this at all. Impossible. Yeah. Okay, now you all have to be very careful with these words. When iron is corroded, we can use a special word called rusting or rusted. So this one you all have to be careful. I'm not sure whether you all know or not. Do you all know that the word rust is only can be used by iron? Only iron can use the word rust. You never heard people say, hey, the magnesium is rusted. No. Hey, the aluminium is rusted. No. Okay, rust is a word that only used by iron. So everyone, look at here. Rusting means corrosion of iron. So when iron lose electron to become Fe2 plus, the iron undergo corrosion. When iron undergo corrosion, you can say rust. Okay, so I just want to keep on emphasize one thing. The word rust only can be used by iron. All other metal cannot use the word rust. So all other metal, they only can use the word corrode. You got it? That's why everyone listen to what I'm going to say. Iron, rust. Magnesium, corrode. Aluminium, corrode. Zinc, corrodes. Understand? All other metal, if they donated electron to become metal ion, they corroded. Only for iron, when you donated electron, you call it rust. Now it comes to one point. Some people ask, Mr. Martin, if I got iron, if the iron donated electron to become the ion, can we still use the word corrode on iron? Yes, no problem. Corrode can use for any metals. It's just that if you are iron, instead of using corrode, you also can use the word rust. Understand? That's it. That's what you all need to know about rust. Very, very important. This is so important. Your textbook won't tell you one. Your textbook just throw a lot of information in one single page and that's it. And very hard to understand one. Okay? That's why, you know, the problem is this. If you look at textbook, reference book, there's this pointless one. Not to say they're useless. Okay? Sometimes they are good as in they have information, but they didn't explain. The problem is the explanation. Just like this. Today, you go to copy the notes from your friend or your senior. Your senior is a straight A+ student. Would it be helpful? Not really. Not really. Okay? Because you copy the notes from straight A+ student, but you don't know how to use the notes, no point. Yeah. So for me, the best notes is actually the notes prepared by the students' own self. You guys are quite lucky. You guys are the second batch of students I give notes. For the past 18 years I teach, I never give notes to students. I just write on whiteboard. The students have to copy everything on the whiteboard. They have to, okay? But now to cut short the process, that's why after every lesson, I give you a PDF file. Is it okay? But it will be even better if you can look at the PDF file and create your own notes. It's okay one, all right? But it's optional, depends on you, okay? So because why I want students to create the notes, because your own notes is always the best one. And you can use your own way. Some people love to draw a lot of things on the notes, like draw rose, flower, dragon, Pikachu. It's okay. Some students, they prefer, okay, like to write some Mandarin word or Tamil on the explanation part. Perfectly fine, no problem. As long as it helps you to understand your notes better. Okay, finish, huh? Okay, let's go on. Okay, everyone know, we know already what is corrosion. When metal loses electron, become metal ion is corrosion. So when the iron corroded, you can call it as rusting. Okay, the next one you need to know is this. There are two types of corrosion when you come for iron. Remember I said we always focus the corrosion of iron. That's why if you look at the textbook, they call rusting of iron. We're focusing on iron. Okay, there are two types of corrosion. The first one called atmospheric corrosion. Okay, atmospheric corrosion, also known as normal rusting. Normal rusting. Okay, so how you know the question is a normal corrosion? When the question only gives you one metal, and the metal must be iron. Okay, so if you only see one metal given, so it will be a normal rusting, which is called atmospheric corrosion. Okay, the second type of corrosion is called electrochemical corrosion. Okay, how on earth we know the question is actually electrochemical corrosion? When you have two metals. These two metals, they must be connected together. I will talk more about this connection later. You have two metals, okay, you have two metals. These two metals, one of the metal must be iron, okay? The iron pair with another thing. For example, you have iron combined with copper, two metals. This is called electrochemical corrosion, okay? You have iron combined with zinc, two metals, is electrochemical corrosion. So some students will ask me, sir, if I got magnesium and zinc, two different metals, can we call it electrochemical corrosion? The answer is no. Why? In SPM, the corrosion must have iron. So no iron cannot. So SPM, the corrosion, we keep focusing on iron. Yeah? So remember that. No iron cannot. Okay? Okay, so now you all should know already. What is atmospheric corrosion and what is electrochemical? Let me show you quickly. These are some questions that we will do in a short while, probably after 30 or 40 minutes. These are the questions that we will do together a lot. Yeah. Okay. So let me ask you. So the first question is this. Put your eyes on here. Okay. This is a piece of iron. This is a water. Okay. This is iron and this is water. I will talk more about this in a short while. My question to you, very simple. This diagram show you atmospheric corrosion or electrochemical corrosion? Atmospheric. Why? Only one metal. Yeah, only got iron, nothing else. Okay, so another one, very easy. So look at here, this diagram. So this diagram, you can see you have iron nail. So and then it coiled with another metal X. Iron is one metal, metal X is another metal, two metal, electrochemical corrosion. Understand? So we learn step by step. Okay. So first of all, when you get the picture, you know, oh, this is atmospheric corrosion or this is electrochemical corrosion. Yeah. So now only I will go further. I'll teach you detail one by one. Okay. So let's start. So I want to teach you something about atmospheric corrosion. Okay, So to do atmospheric corrosion, what is atmospheric corrosion? Atmospheric corrosion means normal rusting. While you all learn about normal rusting as early as your primary school. Okay? In primary school, you already learn what is rusting. Okay, so can we do a revision on primary school? Okay, on primary school, you all should know when you want rusting to occur, you need 3 conditions. Okay, if you want rusting to occur, you need 3 conditions. The first one, if you want rusting to occur, you must have iron lah. No iron, how to rust? Am I right? Second one, we also learned that rusting need water, right? Am I right? We learned this also in primary school. Okay. Last one, in primary school, we learned that rusting need air. Yeah, air. Primary school. Primary school. Now, are you taking UPSR now? No. Okay, you are taking SPM paper. So SPM paper, I want all of you to change one thing. This air change to oxygen. Understand? Why? Inside the air got many gases. In air, you have carbon dioxide. In air, you got oxygen. In air, you got nitrogen. You have many gases in the air. Which gases you need for the rusting? Oxygen. Is it okay? So in SPM, if they ask you, what is needed for rusting? 3 things. Iron, oxygen, and water. All good? So without any one, rusting won't take place. So if you only got iron and water, no oxygen, cannot. If you only got iron and oxygen, no water, cannot. You must have all of them in order for the rusting to take place. Okay? I hope everyone can understand. Huh? Okay, next one. All of you must know what is the scientific name for rust. So we all heard about rust, rusting, rusted, yeah? A lot. But what is the proper name of rust? The proper name of rust is called hydrated iron trioxide. And you not even need to purposely memorize. It makes perfect sense. One. I'll tell you why it makes perfect sense. Guys, hydrated means what? Water. Hydrated means water, right? Rusting need water. Am I right? Iron 3. Iron 3 come from iron. Hey, why is iron 3 not iron 2? Common sense, guys. Why is iron 3 not iron 2? In SPM, you learn that Fe2 plus, what is the color? If anyone can remember, Fe2 plus what color? You learn in Form 4. Green. Fantastic. Allow me to ask you a question. Your rust is green color? No, ma. What is the color for rust, everyone? Brown. So who is brown? Fe3 plus. You get it? You learn this in Form 4, Chapter 6, right? Fe2 plus is green. Fe3 plus is brown. We know the rust is brown. That's why it's iron 3, not iron 2. Make sense? Next one, oxide. What is oxide? Oxygen. See that? So rusting need iron, water, and oxygen. When iron, water, and oxygen combine together, they form the brown color rust like this. Okay? This brown color rust like this, the name is called hydrated iron trioxide. That's it. Okay? Hydrated iron trioxide. I'll show you in a short. Okay? All right. So that's the thing. All right? So if they ask you what is the name of rust, make sure you write hydrated iron trioxide. Okay, so now we know the name already. What about the formula? Okay, first and foremost, I want you all to know this formula. No need to memorize. No need to memorize. I just show you only. So this Fe2O3 is iron trioxide. Okay, this one, you have a dot and XH2O. This X can be any number. Example, okay, Fe2O3 dot 4H2O, Fe2O3 dot 7H2O. When you see a dot and a water at the back, means they carry along. So this Fe2O3 carry the water. When you carry the water, it is hydrated. That's why we call it hydrated iron trioxide, because you carry water along with you. Is it okay? If you don't know how to write this formula, perfectly fine. It's okay. Yeah, they won't asked about this formula at all. So what you need to know is only the name. You don't know the formula, perfectly fine. Yeah, okay. Because I don't want you to waste the time to memorize the formula. It's meaningless for you. Of course, you can. I won't stop you, but no point doing that. No point. No need to waste your time. Okay. If you want to memorize, spend more time to memorize your bio and sejarah. Don't waste your memory in chemistry. Really. Okay. Okay, that's right. So now the next thing. So for the next 30 minutes, I will teach you the detail, all the technical knowledge you needed for this atmospheric corrosion and electrochemical corrosion. So we plan to finish this thing in the next 20 to 30 minutes. Okay, so let's do it. So now I want you all to know how atmospheric corrosion occur. So if you want atmospheric corrosion occur, you must have three things. Number one, this is the iron. Yeah. Number two, this is the water. Number three, oxygen. Where is the oxygen? Here, surrounding all the oxygen, right? Turn on. Okay. This whole thing exposed to the air. In the air got oxygen. So you have oxygen. Okay, you have oxygen in the surrounding. Yeah, that's it. Okay, oxygen is everywhere. Okay. So now you have these three things, you know you can rust. Okay, now I want to explain to you step by step how rusting occurs. Rusting involves 4 steps. Okay, there are 4 steps in rusting. Don't feel stressed, just go on slowly. Yeah, we just go on slowly and I will show you how it works. Okay, first and foremost, rusting starts when iron atom go to donate electrons. So when iron donate electron, it become iron 2. Okay, Fe throw away 2 electron to become Fe2 plus. So I explained early on today why you won't get Fe3 plus. Because if you want to become Fe3 plus, you need to donate 3 electron, which is harder. Yeah, donate 2 electron is easier compared to donate 3 electrons. So when iron donate electron, you will donate 2 electrons, so you become iron 2. So this is how the rusting started. Normally, rusting started in the middle of the iron. So let's say this is the iron bar. Somewhere here in the middle, you can write this. Fe become Fe2 plus and 2E. Okay, when this process happen, you will see one thing. You see, when iron become Fe2 plus, what happened? Metal become metal ion. So we learned early on today, when metal become metal ion means what? Some of the metal will get eats away. Some of the metal will disappear because corrode means disappear. So you can see here. Look at the next picture. You can see this one. Can you see? This part disappear already. Yeah. So the middle part, you will see some of the iron disappear. Why? Because when Fe become Fe2 plus, when metal become metal ion, they corrode. That's it. Okay. So that is the first thing you will see here. And make sure you know how to draw this diagram. In SPM, they do ask to draw this diagram previously, not very frequently asked. They didn't ask so frequently, but they asked before. So it's good to know how to draw. Okay, just draw a rectangle for iron, draw a semicircle for the water, and put some dotted line. This is water. Okay, all right, simple as that. Okay, so now when iron donated electron to become Fe2 plus, the next thing you must know, everyone, where the electron will go. Okay, where the electron will go. So all the electron donated by iron, like this, the purple color electron here, they will go to this corner and this corner. They will go to this one, here and here. So this corner is called what? This corner is this. Electron move to the edge of the water droplet. Okay, all the electron will go to here, the corner of the water droplet. Okay, why they go here? Why? Why they go there? Same thing, for the reason, they not go there for fun. Okay, why? So everyone, I want you all to imagine this. Okay, I want you all to imagine this. Zoom in. Okay, let's say this is you. You are the human. Okay, which is you are the electron. Okay, why you not going here? Why you not going here? Why you come to here? Okay, why are you standing at this one, this corner? So sorry, my bad. Okay, why are you standing at this corner as well as this corner? Why? Because remember, everyone, rusting need iron, oxygen, and water. This is a point whereby you can get water and oxygen at the same time. At this point, you have oxygen. At this point, you also have water. True or not? This is a point where you can get water and oxygen easily. But imagine this, everyone. Okay, imagine this, huh? Okay. If let's say I go here. So what happened here? Here got water, but no oxygen. You see that? Right? I don't want. I want to go to a place which got oxygen and water. Okay. So I found out that at here and here, I can get both of them. I can get oxygen and water easily. That's it. So that's why the electron will move to these two corners. We don't call it corner lah. We call it edge. So electron move to the edge of water droplet. So why electron go there? Again, electron not go there for fun lah. Okay. So we know that in redox, you need somebody to donate electron. Of course, you need somebody to receive. Okay. You always need someone to give electron and someone to take electron. Just now we know iron donated the electron. So now who will receive electron? Remember, rusting need three fella: iron, oxygen, and water. So the iron, they will donate electron, and the electron will be received by oxygen and water. This one you have to be careful. Electron is received by oxygen and water together. The electron not received by oxygen only. The electron not received by water only. But the electron is received by oxygen and water together. Okay? So everyone, put your eyes on here. Electron received by oxygen and water. When electron received by oxygen and water, you will form hydroxide ion, which is OH minus. No need to memorize. Use common sense. How to use common sense? Look at here. This is oxygen. This is water. Oxygen and water is needed for rusting. So when iron donated electron, electron will be received by oxygen and water. So they will receive electron. Common sense, huh? Oxygen is neutral. Hydrogen is, the water is neutral. Something neutral, when they receive electron, what happened? They become negative ion. So here you have O. Here you have H. Who is the negative ion? OH minus. Isn't it? Common sense. I didn't memorize. Okay? I got go to predict the formula. That's what I do. Now, balance the equation. Put a 2, put a 4 here. Balance the equation. Last one, balance the charge. Left-hand side, no charge. Right-hand side, -4. 0 and -4. The charge differences is 4. You need 4 electrons. If any one of you you have the sharp eyes, you should notice that this formula looks a bit familiar. You should notice this formula looks a bit familiar. Actually, this formula quite alike electrolysis. Electrolysis, what happened? OH minus discharge to become oxygen and water. So actually, this equation is the electrolysis, but opposite. They go terbalik. Okay, in electrolysis, OH minus discharge to get oxygen and water. Now you go the other way around. Oxygen and water receive electron to become OH minus. Is it okay? So I want all of you to know, when iron donated electron, the electron is received by oxygen and water. When oxygen and water receive electron, they become OH minus. So make sure you know how to write this particular equation. Okay? So now, what happened next? When you have a positive ion and you have a negative ion, positive and negative fall in love with each other. True or not? Positive attract to negative. So you see, now, just now I have Fe2 plus, and now I got OH minus. Positive and negative, they will combine together. So what happened? Fe2 plus, they will combine with OH minus. So what is the final formula? Okay, we learned this in your Form 4, Chapter 3. Fe2 plus and OH minus. When these two ions, they have different charges, we do a cross method. We learned this in Form 4, Chapter 3. This number 2 come to here. This one, no number. No number means number 1 come to here. Is it okay? So at the end of the day, what is the formula? Fe got 1. Chemistry 1, no need to be written. No need to write 1 in chemistry. This OH got 2, but you have to be careful. If you write OH2 is wrong. Because why? These 2 should be given to the O and the H. You need to put a bracket here. Is it okay? Because if you don't put a bracket, these 2 only given to the H, which is wrong. You want the 2 here to be given to the entire OH. That's why you need a bracket here. So FeOH2. Okay, so you get this FeOH2. Okay, now how to balance the equation? 1 Fe on the left, 1 Fe on the right. 1 OH on the left, 2 OH on the right. Put a 2. So that's it. So now we have successfully write this equation, which is here. Okay, Fe2 plus combined with OH minus, you form FeOH2. FeOH2, what is the name? Fe here is called iron. This iron is made of Fe2 plus, so is iron 2. OH is called hydroxide. So it's called iron 2 hydroxide. All good? Okay, and make a wild guess. Make a guess. You think this iron 2 hydroxide, what is the color? Make a wild guess. Agak, what is the color? What is the color? Iron 2 hydroxide. Brown? No, cannot be brown. Green. Iron 2. Fe2 plus, right? Fe2 plus. So anything got iron 2, Fe2 plus, the color should be green. That's why I just want to tell you this. Sometimes when you see rusting, you won't get brown color immediately one. For example, you have a pipe. This pipe, when it started to rust, you will see actually it's green color first. After the green color, after a few days, then only green color become brown. Okay, maybe my drawing not so good. I show you a proper picture. Put your eyes on here. You see that? All right. So you see, this is this is iron. So you see, so this green color it's iron 2 hydroxide. Okay, this green color is iron 2 hydroxide. So this green color, the rusting not complete yet. Rusting only complete when you become the brown color, which is what I will show you in the next steps. Is okay? So I just want you all to learn a simple knowledge here. When you have a normal iron, when it undergo rusting, it is not becoming brown solid immediately. You don't expect the iron immediately become brown color rust. No, the iron will form a green color things first, then only it become brown color. Is it okay? So why got green color? Because like what I say, okay, why got green color here? Because first and foremost, this iron Fe donated electron become Fe2 plus. Okay. Then the electron donated by the iron received by oxygen and water. Oxygen and water receive the electron, so you become OH minus. Now you have a positive ion and also negative ion. They fall in love with each other. So positive and negative ion combine, you form FeOH2. This FeOH2 inside got Fe2 plus. That's why the color is green. Is it okay? So everyone, let me know up to this point. Let me know in the chat box. Is it make sense to you so far up to now? So hope you all can see this. That's why I need some picture here so you all can imagine the whole thing in a better way. All right. So now let's finishing the last step. Okay. So now we know we're not finished yet because the rust should be brown. We only get the green color things until now. So let's do the last thing. So the last thing, how to change the green color here to become brown color here. So that's the last step. The iron 2 hydroxide, which is the green color, further oxidize. Oxidize means oxidation. So the iron 2 hydroxide oxidized by air. Sir, if I don't want to write air, can I write oxygen? Yes. Okay. So the iron 2 hydroxide oxidized by air to form a rust. Rust, it's hydrated iron 3 oxide, which is brown color. So to make it simple, like this. This green color is iron 2 hydroxide. So this green color, when you expose to air, when this green color exposed to air, they react with air so that they form the brown color. The brown color is hydrated iron 3 oxide. This hydrated iron 3 oxide, iron 3 is brown color, and this is your rust. Finish. That is everything you need to know about atmospheric corrosion. It's not easy, but it's not very hard. Okay, it's not easy, but not too hard actually. Yeah. So I hope everyone can get some rough idea what is atmospheric corrosion all about. So you have an iron, the iron will donate electrons. After iron donated electron, you become Fe2+. So where the electron will go? The electron go to the corner of what? Water. Yeah, the electron go to the corner of the water, which is here. So when electron go there for what? Electron go here because the electron will be received by oxygen and water. So when oxygen and water receive the electron, you form OH minus. So this OH minus and Fe2+ combine, you form FeOH2. That's why you should get some green color thing first. So this green color thing, when you expose to air, they will react and become the rust, which is the brown color. That's why at the end of the day is this. Okay, so that's why you see this. Initially should be green, then only become brown. Okay, so that is everything that you need to know about your atmospheric corrosion. Okay, so now before I go on and teach you electrochemical corrosion, which is what we will do in the next one, I would like to spend some time to do some question with you about atmospheric corrosion first. There's no point we keep rushing if you don't understand how to do. Okay, so just a quick one, a simple one. So let me show you this here. Here we go. All right. So we do two questions here first before we continue and learn something new today. Okay, the first question, this is a real SPM past year paper, a real SPM past year paper in the year of 2013. So you can see the picture. This is an iron. They told you this is water droplet on a piece of iron. So when you only have iron, only have one metal, this is atmospheric corrosion. What happened at cathode? So where is the cathode? They show us cathode is the corner. So what happened at corner, everyone? Okay, in the middle here, iron donated electron. In the middle, iron donated electron become Fe2+. The electron go to the corner, electron received by oxygen and water. Oxygen and water receive electron to become OH minus. So the best answer is C. Is it okay? Oxygen and water receiving electron to become OH minus. Very straightforward. Yeah, I don't think this question is hard. I don't think this question is hard. Okay, one more. This is another question. Same thing, SPM 2006. This is 2013, 7 years apart, but the question is the same. What happened at cathode? Same thing, all right, cathode is here, they show you corner. So at corner, the oxygen and the water, they will receive this electron. This is even good. This is so kind. They draw for you, okay? You can see electron go there, yeah? So electron go there, so the electron received by the oxygen and the water. That's it. So the answer is C. Okay? I don't think it's hard. Okay? I don't think it's hard. Okay? So the questions are quite straightforward lah, if they want to ask in objective. Okay, I think not a big issue lah. Not really a big issue. So with that being said, we are all done with atmospheric corrosion. Okay, so let's use again 1 minute to summarize, to do a quick recap. What is atmospheric corrosion all about? Atmospheric corrosion only involve one metal, which is iron. Okay, iron need three things. Sorry, rusting need three things: iron, oxygen, water. Okay, you need iron, you need oxygen, you need water, all of them. Then only got rusting process. So how rusting works? First and foremost, the iron will donate electron to become Fe2+. So the electron donated by iron need to go somewhere. Where they go? Corner, the corner of water. Okay, so electron go to the corner. Why? Electron received by the water and the oxygen. When electron received by oxygen and water, they become OH minus. So then what happened? The Fe2+ that we produced just now and the OH minus ion, these two They will combine together to become FeOH2. FeOH2 is called iron 2 hydroxide. It is green color. Okay, remember, rusting, you won't get brown color directly. You should get green color first. Then this FeOH2 continue to react with air to become the rust, which is the brown color things. What is the scientific name for rust? Hydrated iron 3 oxide. End of story. Okay, that's everything you need to know for atmospheric corrosion. Not very hard. Okay, so we are done, huh? So now let me teach you another concept. Okay, the next concept that we will learn, and this is much more interesting. The next concept is much more interesting. This is called electrochemical corrosion. This is called electrochemical corrosion. Okay, again, how we know the question is actually electrochemical corrosion? You must have two metals, and these two metals, they must expose to oxygen and water together. You must have two metals. These two metals must expose to oxygen and water together. Then only it is electrochemical corrosion. And these two metals, they must be in contact. In contact means what? In contact means that they must be touching directly or indirectly. I repeat, in contact means that these two metals, they must be touching directly or indirectly. Okay, what do you mean by touching directly, indirectly? Okay, let me show you something here, everyone. I need your attention. Okay, you see, when you only have a piece of iron exposed to water and surrounding here got oxygen, this is atmospheric corrosion. You see, when you have two metals, iron and zinc, are they connected? Yes, they connected. When two metals connected and these two metals together, they expose to the water and oxygen, then it is electrochemical corrosion. Understand? Okay, you must have two metals. Okay, you must have two metals. These two metals, they must be connected. These two metals, they must be exposed together to oxygen and water. Now, allow me to ask you a simple question here. Let's say today we do electroplating, something we learned previously, electroplating. This is an iron spoon. Outside the iron spoon, got a layer of silver. We have silver layer outside, and here got water on the iron spoon. Okay, here got water on the iron spoon, and surrounding here got oxygen. So my question is this: is this situation electrochemical corrosion? Is this electrochemical corrosion? Yes or no? Yes or no? Okay, let's see the reply. Okay. Okay, so I can see somebody say yes, somebody say no. The answer is no. It is not electrochemical corrosion. Why? Why is no? Okay, listen carefully, especially for those of you who say yes. Yeah, so you have to be careful. It's no. Why? To be electrochemical corrosion, you must have two metals connected. Do you have two metals connected? Yes. Iron spoon connected with silver layer. They are connected. Okay. Are they exposed to oxygen and water together? No, because you can see the silver layer covered up the iron spoon. So who is exposed to oxygen and water? Silver only. Silver only. Iron hide inside. So iron is like hiding at your home. You are not exposed to stranger. You get the idea? So only the silver is exposed to the oxygen and water. It is not electrochemical corrosion. You got it? So please be careful. Many people, when they see two metals, they thought it's electrochemical corrosion. No, it's not. Okay? So this is a good one. So please make sure everyone knows what is this. Okay? So just now I can see like for online, for my online class just now, there are quite a number of you answer no. Are you okay? Do you understand better? A few of you answer yes. So do you guys have a better idea why it is not electrochemical corrosion now? So please be careful, huh? If you want to be electrochemical corrosion, you must have two metal. Yes, both of the metal must be exposed to oxygen and water. Yeah. So in this case, because when we have electroplating, the iron outside layer got silver. So only silver is exposed to oxygen and water. So when you only have one metal exposed to oxygen and water, it is not electrochemical corrosion. Okay, one more. Look at here. This picture, is it electrochemical corrosion? The answer is yes. Why? I got two metals. Are they connected? Yes, by wire. You see that? Just now, these two metals connected by touching directly. Now, these two metals, they are not touching directly, but they got wire. They still connected. They still connected. So when these two metals, they are connected, and then they exposed to water and also oxygen on the surrounding, they are electrochemical corrosion. Guys, allow me to ask a simple question. If there is no wire, is it electrochemical corrosion? No, it's not. So please be careful, so you don't think, oh, got two metals, must be electrochemical corrosion. No, the two metal must be connected. Connected means what? They can touch directly or they can connect by wire. Okay, so this is very, very important. Okay, so what about the last question? The last question here, everyone. Okay, the last question. This is interesting. The last question, this is interesting. Okay. Do you think this is electrochemical corrosion? Yes or no? Look at the last picture and answer me in the chat box. Do you think this is a diagram for electrochemical corrosion? Okay. If you say no, why? If you say no, why? If you say yes, why? All right. So I can see, okay. Okay. So let me tell you a common mistake for a lot of students. Let me tell you a common mistake for many students. Okay, first of all, if you want to be, okay, first of all, let me tell you the truth first. Let me tell you the truth. Is it electrochemical corrosion? Yes. Is yes. Is yes. Okay, why? Why is electrochemical corrosion? Listen carefully. Listen carefully. Iron is one metal. Copper is another metal. Are they connected? Yes, they connected to wire. So these two metals, are they exposed to oxygen and water? They are exposed to water, right? But some students will say, sir, they are not exposed to oxygen. Looks reasonable, but it is nonsense. Why? Although you don't see oxygen here, but brother and sister, ladies and gentlemen, please understand a simple thing. Oxygen can dissolve in water. If oxygen not dissolved in water, how this cute fish can survive? You got it? Okay, how the fish can survive if the oxygen cannot dissolve in the water? You got it? So oxygen can dissolve in the water. So in the other word, water got oxygen inside. That's why although this picture, which I purposely trap you, I don't show you oxygen, but there is oxygen. This is water. Water inside the oxygen. That's why today, if you put a fish, they survive. Understand? Because they are oxygen in the water. Got it? So this is electrochemical corrosion. So can you see I purposely set many conditions here so that you're aware. You're aware. Okay? Because if you look at textbook only show you one picture. That's it. Okay? Then all in sudden, when it got wire, you don't know it is electrochemical corrosion already. When they don't give you the oxygen, they only give you the water, you thought it is not electrochemical corrosion. No. So everyone, one of the biggest takeaway, one of the biggest learning for today, water inside your oxygen. Okay? There are some oxygen inside the water. All right? So, okay, I get a question from Irene. If there is no oxygen, only water, there's no rusting, right? Okay, yes, Irene. If let's say we can take away all the oxygen from the water got no oxygen at all, then no rusting, because rusting need oxygen also. Okay, all right, finish. Okay, everyone, let me know in the chat box, are you guys okay with this concept? Do you understand why even I don't draw oxygen here, still got electrochemical corrosion?
Sure. How do you remove oxygen from water?
You have to go through a process that you can call osmosis. Osmosis can do, okay, you can do osmosis, but you can put in a very special membrane, so to really filter off the gases you want. Because membrane you can control the size, you can control the size, what kind of gas you want it to pass through, what kind of gas you don't want to pass through. You can do it to remove the oxygen from the water. Okay, but no point doing that lah. No point doing that lah. Normally we don't do that. Normally we don't remove the oxygen from the water. Normally we don't. Okay.
Teacher, if you were to throw some guppies in the water, can you remove oxygen?
Again, sorry?
If you throw some guppies inside the water.
Not really. Not really. Okay, so now let's move on. Okay, so now we already understand what is electrochemical corrosion. You must have two metals, and these two metals must be connected, and these two metals must be exposed to oxygen and water together. Okay, all right. So now the next part, for the next 15 minutes, we will learn the important concept of electrochemical corrosion. Now, what is electrochemical corrosion all about? Okay, you see, now here I want to teach you some nonsense thing first. I want to teach you some non-chemistry concept. Then only I bring you back to chemistry study, because if you really study by textbook, it's very boring, very boring. Okay, so now everyone look at here. Okay, I'll teach you a simple concept of electrochemical corrosion. So this is the one. When two metals exposed to oxygen and water, only one of the metal will die. Die means corrode. So when you have two metals exposed to oxygen and water, only one of the metal will corrode. Example, when you have copper and iron, these two metals exposed to oxygen and water, only one of the metal will die. Maybe iron will corrode, maybe copper will corrode, only one. You won't get both of them corrode at the same time. Clear? So we are playing a simple game. This game is this. Got two participants, got two people join the game. These two participants, they are metal. Only the rule of the game is very simple. Only one person need to die. That's it. Okay, you won't kill both of them. You only kill one of the metal. Okay. So now the question is, who will die? Which metal will die? Die means corrode. Okay. Remember, die means corrode. But don't write die in exam. All right, write corrode. Right? Die is a simple way for you and me to understand. So it's a secret between you and me. Yeah. So don't write the word die in exam. Okay. Because I got one student really do that. Okay. Many years ago. I think 10 or 9 years back, there's one student, super naive one. Go to write one. Okay. Iron will die. Then the teacher mark the paper and then put a big question mark. What you say? What you say, right? So don't do that, okay? So die is only, I try to simplify it so that you can imagine, but you are not allowed to write these words in exam. Yeah? Okay, now let's go on. Okay, so now, how to know which metal will die? Okay, the metal will die is the more electropositive metal. Okay, what is electropositive? We learned this previously in metal displacement. If you all remember, let's do a 1-minute revision. Electropositive means the metal who is higher in ECS. Okay, any metal who is higher in ECS, they will die faster. Die means they will corrode. So the higher the metal in ECS, the more easy for the metal to corrode. Simple as that. And it makes perfect sense. Why? Look at here. This is your ECS. I hope everyone remembered it. Okay. So you can use your own method to memorize the ECS. If you have been following my class, you know my method is kalau nak kahwin mesti ada zakar, fantastic, sebab papa hendak cucu anak. That is my way. But you can use your own style, you can use your own method. It doesn't matter as long as you can memorize your own ECS. Yeah, right? So this is the ECS. So you all should know, ECS is a table that tells you who love to donate electron. The higher you are in the ECS, you are more and more keen to donate electron. Okay, when you are very keen to donate electron, I can say you are more electropositive. Example, magnesium and also iron. Magnesium is higher than iron in ECS. Magnesium is more electropositive than the iron. So means what? Magnesium is more and more keen to donate electron. So when you keen to donate electron, what happened? When magnesium donated electron, magnesium become Mg2 plus. Listen, listen, listen. When a metal become metal ion means what? They corrode, they die. You get it? So the higher the metal in ECS, means they love to donate electron. When metal donate electron, they become metal ion. When they become metal ion, they corrode, they die. Understand? Simple thing, huh? So the simple idea, the higher the metal, the more easy for the metal to corrode. Okay, the more easy for the metal to die. So let me teach you what happened here. Okay, so today, if you have iron connected with any metal higher in ECS, let's say magnesium, you see, huh? All the metal higher than iron in ECS, they can prevent the rusting. All the metal higher than iron in ECS, they can prevent the rusting. Okay, so for example, today if you connect iron with magnesium, look at your ECS, please. Magnesium is here, iron is here. So magnesium is higher than iron in ECS. So the higher the metal, so the metal will die. So what happened? Magnesium will die, iron will survive. Is it okay? So a simple way to imagine is this. All the metal higher in ECS, they will die. So this is what will happen. Okay? When this is iron connected to any metal higher in ECS, okay? Any metal higher in ECS, okay? They will die first. So this metal, I will die for you, okay? Example, magnesium. Magnesium is higher than iron in ECS. Magnesium love to donate electron. When magnesium donate electron, what happened? Magnesium corroded. When magnesium corroded, what happened? Magnesium died. When magnesium die, iron need to die or not? No need. Because remember our game, only one person die. So when magnesium die, iron no need to die. So iron survive. So that is what happened. Okay? So now, next one. All the metal lower than iron in ECS, they will speed up the rusting. So if you have any metal who is lower than iron, rusting still take place, and the rusting will be even faster. What do I mean? You see an example. Today, if I got iron connected with somebody lower in ECS, let's say copper. So you see here, everyone, this is iron, this is copper. Who will die? Higher one. So who die? Iron will die. Okay? Not only iron will die, what happened here? So you see, everyone, look at this picture. The metal high in ECS, we learned before. ECS also, we learned about gangster bully concept. We learned in metal displacement. The one higher in ECS, they are more powerful gangster. More powerful, you see what? Can you see the body is big one? Magnesium is so big compared to iron. So I am super big and muscular. I protect you, I will die for you. Okay, now look at here. If you have copper, copper is lower than iron. When you're lower than iron, copper should be smaller. You see, if iron look like this, copper should be like this. Okay, the lower you are, the weaker you are. So copper, so in this case, copper not only will not die for me, but what is worse, look at this picture. Okay, all the metal lower than iron ECS, they will speed up the rusting. Speed up rusting means what? I will push you to die. Okay, I'll push you to die. So all the metal lower than iron, they didn't die for the iron, but instead they push the iron to die faster. That's why all the metal lower than iron will speed up rusting. So the iron die faster. Okay, so that's why you can see here, when you have copper lower than iron, iron will die faster. That's it. So this is a simple way to understand the whole thing. Is it okay? If you read the textbook, very boring one. Very, very boring, because full with words, full with equation. That's why I teach you a concept. What is the concept? Die concept. Okay? Who will die? Okay? So let me know in the chat box, are you guys okay with this die concept? Okay, so it's quite easy lah. So this is very, very simple. Okay, this is a very simple idea for you to understand the whole concept. Yeah. Okay, anyway, let's look at the technical part. Let's look at the technical part of this knowledge. So let me show you this. I will use two examples. I will use two examples for demonstration. I'll use two examples here for demonstration. Then we are all done already. Yeah. So let me show you this. Okay. Follow me, please. Listen carefully. If anything you're not sure, don't be shy. Ask me. Okay, everyone, look at this picture. Okay, first and foremost, is this electrochemical corrosion? The answer is yes. Why? Two metals connected together, both of them exposed to water and oxygen on the surrounding. Even no oxygen here, no problem. There are some oxygen in the water. Is it okay? Because we learned early on today, there are some oxygen in the water. Okay, so we know this is electrochemical corrosion. And remember, what is electrochemical corrosion? Two person, one person die. Yeah, only one metal need to be corroded. So now the question is, who will be corroded? So look at your ECS, blah, 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 blah. You will notice zinc is here, iron is here. So zinc is higher than iron in ECS. So zinc will die. So iron will survive. Is it okay? The metal higher will die. So why zinc will die? Remember, in ECS, the higher the metal, they love to donate electron. So when you compare zinc and iron, who love to donate electron? Zinc. So let's write this. Zinc is more electropositive than iron. So zinc is more keen to lose electron. Is it okay? When you are higher in ECS, you are electropositive. When you're electropositive, you love to donate electron. So when zinc donated electron, what happened? I am a zinc. When I donate electron, I become metal ion, so N2+. So I put 2 electron here. I hope everyone know how to write this half equation. Is it okay? So the zinc atom will lose. Why I call atom? Because the zinc here is alone. Anything alone is atom. Zinc atom loses 2 electrons in order to form this fella, zinc ion. All good. So now we know already, the zinc will donate electron. When zinc donate electron, zinc is corroded, because any metal that is converted to metal ion, they are corroded. So zinc is corroded, zinc die. Okay, so same thing. After you donated electron, you need someone to receive, right? So who will receive the electron donated by zinc? Same thing. No matter who donate electron, no, it doesn't matter. The one receive electron always oxygen and water. Is it okay? I don't care. Iron donate electron, zinc donate electron. I don't care. The one receive electron is always oxygen and water. That's why rusting need oxygen and water. Why? They will receive the electron. Is it okay? So you can say the electron received by oxygen and water to form OH minus. So this is the equation. Finish. Is it okay? Not very hard, right? When you have two metals, zinc is higher than iron in ECS. So zinc loves to donate electron. So when zinc donated electron, zinc becomes Zn2+. When metal become metal ion means what? The zinc corroded. So when zinc die, iron no rust. Iron survive. Okay? Iron survive, no rusting. Okay? That's why I say, all the metal higher the ECS, what they do? Prevent rusting. Understand? They prevent rusting. So the electron donated by zinc received by who? Oxygen and water. Finish. So at the end of the day, what you expect, you can see. You will see this. Because the zinc die means corrode. So the zinc become like this, isn't it? Part of the zinc disappear. Okay, corrode lor. So the zinc corroded, the zinc die. So the iron survive. Survive means what? No rusting. Okay, so that's why zinc prevent the iron from rusting. Finish. There's a special words for this process which I'll teach you in a short while. Okay, but I want everyone to understand this. Not very hard now. Okay, can huh? Okay, we do one more last example. One last example first. Okay, look at here. What about this? Today, what if you have iron and copper? So iron and copper, same thing. Is this electrochemical corrosion? Yes. Why? Two metals connected together. Okay, remember they're not necessarily touching. So if they connect by wire also okay. All right. So two metal connected and then they exposed to water and oxygen. The oxygen can be from the surrounding. Oxygen can come in from surrounding. Oxygen also can be dissolved in the water. So when you have water, oxygen, and two metals, so this is electrochemical corrosion. So same thing. What happened? So remember, when you have electrochemical corrosion, you have two metals. When you have two metals, only one metal will die. Only one metal will corrode. Which metal? Look at your ECS. Blah, blah, blah. Iron, blah, blah, blah. Copper. Okay? So iron is higher than copper in ECS. So iron will die. Simple as that. And not only die, because remember, all the metal lower in ECS, they not only will rust, they will speed up the rusting. It will die faster. It's okay. So this rusting process will be even faster. For example, if you only have a piece of iron, the iron exposed to oxygen and water, it takes, let's say, it takes 4 days for rust to form. So you will see some rust, brown color things over here. Okay. If let's say you have iron connected to copper, so copper is lower than iron in ECS, copper will push the iron to die. So iron will die faster. So this rusting process, instead of 4 days, maybe 2 days, already got rusting. Clear? Okay, so the metal higher in ECS prevent rusting. The metal lower in ECS speed up the rusting process. The lower you are, the more you speed up. Example, you see, today, if this is iron and copper, today this is iron and silver. This one even faster, because if you look at ECS, you see, look at the ECS, iron is here, copper is here. Copper push iron to die, so iron die faster. But if you look at another one, silver, even lower. The lower you are, the more you push the iron to die. Iron die even faster. Is it okay? The lower the metal, the more they speed up the rusting. Is it okay? All right, simple as that. Same thing. The higher the metal, the better they prevent rusting. Like for example, can zinc prevent rusting? Can. Zinc higher than iron can prevent rusting. But if you change the zinc to magnesium, even better. It's okay. The higher the metal, the more they prevent the rusting. Simple as that. So make sure everyone know this concept. Okay, anyway, let's come back to our question here first. Let's come back to this question. All right, so we know that iron is higher than copper in ECS. Iron will donate electrons. So look at here. Iron is more electropositive than copper. So when iron is more electropositive than copper means what? Iron is more keen to lose electrons. So when iron lose electron, okay, Fe become Fe2 plus. Yeah, right. So when Fe become Fe2 plus, so what happened? Iron rust. So remember, normally we use the word rust for iron. We seldom use the word corrode for iron. It's okay, you can use, but the rust is more appropriate. It's okay. Rust is more appropriate when you go for iron. Okay. So same thing. The electron donated by iron need to be received by somebody. Who received the electron? Same thing. Oxygen and water. Oxygen and water receive the electron and you form OH minus hydroxide. So this is what we learned just now. Okay. So after a while, what you will see initially is this. So after a while, what happened? We know Fe donate electron become Fe2 plus. When iron become Fe2 plus, you will see iron corroded. So iron corroded, iron become like this. So iron will die, iron rusted. So the copper didn't donate electron. When copper didn't donate electron, copper didn't corrode. Copper survived. So the copper still okay. Is it okay? All right. With that being said, we are all done with rusting. How's everything? Is it okay? Not very hard, right? Okay. So guys, let me know in the chat box. Are you okay? Do you understand what is rusting now?
Teacher, one question is, you see the water droplet contains oxygen inside, right?
Yep.
So how come the electron they hold the left right? Why you go to?
Okay, good question. I'll answer here. Good question. It's a good one. Okay. So guys, I get a good question from my physical class here. Okay. So one of the students is asking, since the water droplet, okay, I go back to the previous one. This is a good question. So let's look at here. So I got a question here. The question is asking, okay, since the water here got oxygen inside, since the water already has some oxygen inside, why the electrons still go to these two corners? Okay, a very good question. A very, very good question. Because, all right, there are some oxygen inside here. So just imagine, okay, this is me. Okay, I want to come out again. This is me. So if I go in here, will I get oxygen? Yes, because oxygen is in the water. Okay, sorry. Will I get water? Yes. Okay. But if you compare to when I am standing here, where I get more oxygen? Here. All right. Because I standing here, my surrounding got many, many oxygen. So that's why these two corners, they still have more oxygen compared to inside the water. Good question. Okay, this is a good one. All right. That's why they still go to the corner. Okay. So although in the water got oxygen, yes, but not as much as the corner. Corner got a lot of oxygen. I go there. Yeah, I go there. So I hope you get a better idea. Okay, that's how it works. Okay. Anyway, it's a good question. This is a good one. All right. Okay. Okay, so we are done with this. So we have one more last part, which is experiment, how to do experiment for rusting, okay, which I'll cover with you, okay. But I hope all of you understand what is rusting all about. It's not hard because some students thought rusting is super complicated. Not really, okay. Rusting, actually, the question is quite doable. It's quite doable. Okay, so now what we're going to do, now I will show you the experiment for rusting. How to do experiment for rusting? It will take about 10 minutes, 10 to 15 minutes. Then after that, we do some trial exam paper, then we are all done. And we close this chapter already. Yeah? Come, let me show you the last part. So the last part for this lesson is called experiment. So when they want to study, okay, when they want to study the experiment of rusting, they will always use iron nail. Okay, they use iron nail. Of course, if they want to change to other thing, also can. Sir, can they let iron key to rust? Of course they can. Can they let other iron object to rust? No problem. It's just that in SPM, most of the time they ask iron nail. Is it okay? Let me prove to you first. You see here? Iron nail. Yeah? Iron nail. Iron nail. Yeah? Iron nail. Okay? So most of the time, if they want to study about the rusting, they are using iron nail. So for iron nail, how to do the experiment? So look at here, okay? For the rusting experiment, this is what you need. You need a test tube. In the test tube, you need iron nail. All right, you need iron nail. All right. And then here, there are total 3 solutions you needed. So listen carefully. They look long, they look horrible, but we go one by one. The first solution is called hot agar solution. It's called hot agar solution. Sometimes they call it hot jelly. They can call it hot jelly solution or hot agar solution. So you must first understand why you need agar solution here. Why you need agar solution? Okay, the reason is this, everyone. The hot agar solution can do this. It can provide you the oxygen and water. So in the hot agar solution, you have oxygen, you have water, because we need oxygen and water to react with iron nail so that we got rusting. Is it okay? So the hot agar solution here will provide the oxygen gas and water for you. So the second one, not very important, but it's good to know. Hot agar solution can slow down the color change for us to observe. Because, guys, agar or jelly, what it is? Something sticky. Something sticky. So when you have something sticky, the color change, it will be a bit slower. So you can see the color change more clearly. That's it. But this is not important. The most important function of the hot agar solution is to provide you the oxygen and water, because you need oxygen and water for rusting. All good? That's it. Second one. Now this is important. So this one put, okay, 5 star. 1, 2, 3, 4, 5. This is one of the most important solution for rusting experiment. This name is freaking long. Okay, this name is called potassium hexacyanophrate 3 solution. Potassium hexacyanophrate 3 solution. Yes, okay. This name need to memorize. This name need to memorize. It's a must, compulsory. Same thing. If you're having difficulty in memorizing, take a piece of paper, copy this name. Copy 10 times in a day. Copy for 2 weeks. You won't forget for your whole life. All right. Seriously. Okay. If you don't know how to memorize this name, copy this name. Okay. 10 times in a day. Okay. And copy for 1 or 2 weeks, or you copy for 1 month also okay. Okay. Then you will be able to memorize it. This name must memorize. Potassium hexacyanophrate 3 solution. Okay, now guys, why we need potassium hexacyanophrate 3 solution? Put your eyes on here. The potassium hexacyanophrate 3 solution is used to detect Fe2+. Is used to detect Fe2+. If the solution inside got Fe2+, this potassium hexacyanophrate will change to dark blue color. It will give you a dark blue color. Now here, some student will start to confuse a bit. Some student will say, Mr. Martin, I thought Fe2+ supposed to be green. How come it's dark blue color now? So you all have to be super careful. Why? Everyone put your eyes on here. Today, if you have a solution, your solution only got Fe2+, then yes, it is green color. But now what happened? This Fe2+ now combined with potassium hexacyanophrate 3. I'm lazy, I write short form. Is it okay? Potassium hexacyanophrate 3. So when Fe2+ combined with potassium hexacyanophrate, this whole thing will give you a dark blue color. Is it okay? So imagine I'm a police. I'm a police. I am potassium hexacyanophrate. So I'm a police. So my job is to catch only one person, Fe2+. So when I catch Fe2+, so I will change color. I'll become dark blue. Simple as that. Okay? So that's the idea. So potassium hexacyanophrate is a special solution. We use them to combine with Fe2+. So if there is Fe2+, the potassium hexacyanophrate will combine with them, and you will see dark blue color. Okay? Simple as that. The whole solution turns dark blue. Okay? So why this solution so important? Because of this. You see? This is the tips for you. Okay. We know when rusting happens, there is Fe2+. Why? Rusting is what? Rusting means the iron is corroded. So why iron corroded? When Fe donated electron become Fe2 plus or not? When Fe donated electron become Fe2 plus, so the iron is corroded. When iron corroded, rusting happen. So when there is rusting, you always have Fe2 plus. So when you have Fe2 plus, you will see a dark blue color. Is okay? So what do I mean? Which means that when you do this kind of experiment, when you do this kind of rusting experiment, when you see dark blue color, you know got rusting. When you don't see dark blue color, no rusting. Is it okay? Simple thing only. When you do this experiment, you're focusing on dark blue color. When you see dark blue color, there's rusting. When you don't see dark blue color, no rusting. As simple as that. Okay? Why? When you have blue color, means that there is Fe2 plus. Why we have Fe2 plus? Because the iron donated electron become Fe2 plus. When iron donated electron, it means the iron rusted. Is okay? Simple thing. Okay? So that's the logic. Okay? Don't worry, we will do this question later on. So you will have a better idea. So, but I just want you all to know the blue color is very important. When you see blue color, you know the rusting taking place. Okay, the last one. The last solution here is called phenolphthalein indicator. This solution you learn in your Form 4 Chapter 6. This is not a new solution. You learn in Form 4 Chapter 6. Form 4 Chapter 6, when you learn something called titration. Okay, when you learn something called titration, you need to use indicator. You need to use indicator. All right. So we do a very quick revision here. We just do a very quick 3 minutes revision. Okay. So this is something related to your Form 4 Chapter 6. Nothing to do with Form 5. Form 4 Chapter 6. This is indicator. So what is indicator? Indicator is liquid. Okay, indicator, there are some special liquid. They are not solid, they are not gas, they are liquid. What's so special about the liquid? Indicator is a liquid that can show you different color. Indicator can show you different color in different condition. So which means what? When the solution is acidic, the indicator show you certain color. When the solution is alkaline, the indicator show you certain color. When the solution is neutral, the indicator show you certain color. That is what indicator all about. The most popular indicator in SPM got 2. Okay, there are 2 super popular indicator in SPM. The first one is called phenolphthalein. Okay, phenolphthalein. The second indicator called methyl, or some people pronounce as methyl. It doesn't matter with pronunciation. You can read as methyl or methyl. It's okay. Methyl orange. So these are the 2 indicators you learn in Form 4, Chapter 6. So you need to know what is their color in 3 situations. First one is acidic situation. Second one is neutral. The last one is alkaline. Okay, 3 situations. Okay, phenolphthalein in acidic, no color, colorless. Phenolphthalein in neutral, no color. Phenolphthalein in alkaline, pink color. Okay, so which means what? Today, if I have a solution, I don't know this solution is acid, neutral, or alkaline. I can put phenolphthalein. If I put phenolphthalein, the whole thing turn pink color, which means that it is alkaline. If I put phenolphthalein and the whole thing is colorless, maybe it's acidic or neutral. Yeah, that's it. So indicator can give you different color in different condition. Okay, next one. What about this methyl orange? Methyl orange is orange color when it's neutral. When it's neutral, it's orange color. When it's acidic, the color will become darker red. When it's alkaline, the color become lighter yellow. So this is the color of the indicator you need to know. Again, okay, don't look at this and say, wow, Form 5 is hard, brother. This is Form 4. This has nothing to do with Form 5. Many people look at this, oh, Form 5 is very hard. This is Form 4. You already learned in Form 4. Okay, Form 4, Chapter 6. Okay, that's it.
So the orange would be better, right?
Yeah, actually beta orange is better lah. But the more popular one, they always ask phenolphthalein. Yeah, because for simple thing, when they do titration, they just want to make the alkaline become neutral. That's why pink color, they want to change to colorless. Simple thing only.
Yeah, but you let it drop too much, then become acidic.
Of course, that's true. Yeah. Okay, so now we know the indicator. Again, this is not our main concern for today. So because somehow we just covered phenolphthalein, so I think I just do a quick revision with you all. Yeah, I just do a very, very quick revision with you all. Okay, next one. Okay, so we see, everyone look at here. This phenolphthalein indicator is optional, which means what? If you don't want to put phenolphthalein in this experiment, okay, no problem at all. Okay, in this experiment, if you don't want to use phenolphthalein, it's okay. Hot agar is a must. Potassium hexacyanophrate is a must. Phenolphthalein is optional. You put, don't put, perfectly fine. That's why you see some of the question got phenolphthalein, some of the question don't have one. Let me show you. Okay, look at this question. Look at here. Got phenolphthalein or not? This question got phenolphthalein or not? No, only have hot agar and potassium hexacyanophrate. Okay, let me show you another question. This question got phenolphthalein or not? Got. Okay, so phenolphthalein is optional. So don't be panicked. Oh my God, the question don't have phenolphthalein. Something wrong. It's okay. Phenolphthalein not important one. Okay, you put or don't put, perfectly fine. Okay, so now let's look at here. Okay, so what phenolphthalein do? Phenolphthalein used to detect OH minus. Okay, we all learned in Form 4, Chapter 6. H plus means acid. OH minus means what? Alkali. All acid must have H plus, all alkali must have OH minus. So phenolphthalein used to detect OH minus, which is alkaline. So you see, when phenolphthalein is alkaline, what is the color? Pink. Okay, so if the solution is alkaline, then it will have pink color. So you can see when OH minus is present in the solution is alkaline, then you will see a pink color. But remember, this phenolphthalein not important at all. It's optional. You can choose to use it or don't use it. Okay, no worry. In a short while, when we do some question, you will have a better idea. Is okay? We will do some question together. No worry on that. Okay, now let me show you how to do the experiment. Okay, we will do the experiment together for the theory part. So let's look at it. So everyone, I need your attention for this. So put your eyes on here. So we have 3 experiments here. The first experiment, you only put iron nail. Second experiment, you have iron nail coil mixed with magnesium. The third one, you have iron nail mixed with copper. And all of the solution here got hot agar and also the potassium hexacyanophrate. Okay, so maybe I do this. Okay, maybe I do this. Right. I forgot to write in. Never mind. Okay, I just move here. Okay, move up a bit. Okay, so here, in all of them here, we have hot agar. We have potassium hexacyanophrate 3, and we also have phenolphthalein. Okay, for all of them. All right, for all of them, just to show you only. Okay, now allow me to ask you a few simple questions here. Okay, so the first one is this. Okay, so can we go for the type of corrosion here? I think so. When you only have iron, atmospheric, iron and magnesium, 2 metal, electrochemical, iron and copper, 2 metal, electrochemical. Is it okay? That's the first one. That's the first thing we learned. Not the first thing, just now the things that we learned early on today. Is okay? Right? How to differentiate atmospheric corrosion and electrochemical corrosion. Okay, next one, the half equation. Half equation no need to memorize. You see, guys, when you have iron only, who will die? Iron lah. True or not? When you only have one metal, the metal will die lah. Okay, true or not? You don't even need to look at ECS. Okay, because you only have one metal. When you only have iron, who will die? Iron. Iron will die. Die means what? Corrode. So iron will donate electron to become Fe2 plus, and then this is the electron donated by iron. Is okay? So this electron received by who? Electron received by oxygen and water. So the oxygen and water receive the electron so that you become OH minus. Is okay? So everyone, I need you to put your eyes on here. See the half equation here? Okay, Fe become Fe2 plus, then water and oxygen receive the electron to become OH minus. Is okay? So everyone look at the observation. In this case, do you think you will see blue color? The answer is yes. Because when Fe become Fe2 plus, when Fe2 plus is present, the potassium hexacyanoferrate will show blue color. So you will see blue color. Okay, the next one is tricky. The next one is tricky. Will you see pink color? Which is not important. Actually, guys, to be frank, the pink color not important at all. But do you see the pink color? No, you won't. Why? Listen, by right, you have OH minus. OH minus means alkaline. When it's alkaline, by right, should be pink, right? By right, alkaline, you should see the pink color. But how come you don't see it one? This is something to do with common sense. Look at here. This is a blue color. This is a pink color. The blue color is darker than pink color. So when they mix together, you only see the darker color. So the blue color will cover up, it will overshadow the pink color. You cannot see. You get it? Remember, when you have two colors, one color is darker and one color is lighter, you very hard to see the lighter color one. You always see the darker one here. So that's why although you have OH minus here, which is alkaline, by right, you should see pink color, but you cannot. Because the blue color darker than the pink color, you cannot see. If you feel this is confusing, forget about it. The pink color not important at all. The important thing is whether you have blue color or not. Clear? All right. So when Fe become Fe2 plus, so you have blue color. So the observation, a little blue spot can be seen. So you will see this after a while. You will see here got some blue color spot. So when you see blue color means what? Got rusting. Is okay? Okay, next one. So when iron coil with magnesium, you have two metals here. When two metals, it should be electrochemical corrosion. So electrochemical corrosion, how to go about it? So who will die? Look at ECS. Magnesium is here, iron is here. Magnesium higher than iron in ECS, magnesium will die. So magnesium higher in ECS, magnesium will donate electron. So when magnesium donate electron, Mg become Mg2 plus 2E. So the electron received by who? Oxygen and water. So you can see the magnesium will donate electron to become Mg2 plus. The electron will be received by oxygen and water to form OH minus. All good? Simple as that. So what you expect to see, guys, do you think you see blue color here? No, because these two equations don't have Fe2 plus. When you don't have Fe2 plus, you don't see blue color one. Okay? Will you see a pink color? Yes, because you produce OH minus. When there is OH minus, it's alkaline. When the solution is alkaline, it is pink color. All good? Yeah? Simple as that. Okay? Next one. What about this? So when iron combine with copper, what you expect to see? Iron and copper, two metals, electrochemical corrosion. So electrochemical corrosion, how to go about it? ECS, blah, 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 iron, blah, 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 copper. So copper is lower than iron in ECS. Copper will speed up the rusting. So who will donate electron? Iron, because in ECS, the metal higher will donate electron. So the iron will donate electron, become Fe2 plus. So same thing, the electron received by oxygen and water. So you will get this. The iron will donate electron to become Fe2 plus. The electron received by oxygen and water. Okay, so now look at here again. So in this case, what you expect you can see. Okay, allow me to ask a simple question. I want to ask you and I want you to answer me in the chat box. Or you can answer me in the physical class as well. Okay, my simple question here. By looking at these two half equation, do you think we will see a blue color? Yes or no? Do we see a blue color?
Yes.
Okay, let me see the answer from the chat box. The answer is yes. Why? Fe2 plus. Yeah. So when Fe2 plus is produces, Fe2 plus combine with potassium hexacyanoferrate and become blue. So my next question, do you think you will see a pink color? Yes or no? No. Why? By right, there is OH minus. By right, OH minus is alkaline. By right, you should have pink color. But when blue color and pink color come together, blue color is darker. So you cannot see the pink. So cannot see. Is it okay? That's it. Okay. So simple as that. Okay. This is a good question. Okay. So look at here. So now what happened? You not only see the blue spot, you will see a lot of blue spot. Why? Because remember, all the metal lower in ECS speed up the rusting. So when you speed up the rusting, you see many blue spot. You got it? Blue spot means got rusting. When you see many blue spot means what? Rusting happen very fast. You got it? As simple as that. So this is the final summary. In rusting experiment, we only care about the blue color, the blue spot. If you see there is a blue color, it means you have Fe2 plus. When there is Fe2 plus, it means that we have rusting. That is the logic that I want you all to learn today. And we not really care about the pink color at all. Because why? The pink color only tell us whether the solution is alkaline or not. What we want to do, this experiment is about rusting. We don't freaking care whether the solution is alkaline or not. Understand? I don't care. The solution is acidic or alkaline. I don't care. I only care whether it has rusting or not. So we focus on blue. We don't care about the pink at all. Yeah? Okay, so now let me show you some good quality question. And we're going to finish everything already. Yeah? So let's do it. Okay. So I might need to end today's class a bit later. So maybe for extra 5 minutes. Okay, so now it's 9:40. So give me about 10 minutes to do some questions with you all. Yeah. All right. So let's look at this. So this question is this. This question it's Negeri Sembilan. Negeri Sembilan 2021 trial exam paper. So you can see this experiment is about rusting. So what you can see here, first one, a lot of blue spot. So when you see a lot of blue spot, what do you know? Rust rapidly or rusting happen very fast. This one, when you see a small amount of blue spot, just normal rusting, okay? Not too fast, yeah? So when you see pink spot, again, I don't freaking care about pink, right? When there is no blue color means what? No rusting. So remember, we don't care about the pink color at all, okay? I just care got blue color or not. Got blue color, rust. Many blue color, rust very fast. Don't have blue color, no rust. So now the question asks me, based on the experiment, can you arrange the metal which is descending order of electropositivity? When you see electropositivity means ECS. So can we arrange our ECS? Why not? Okay, see, so first of all, this is iron. This is iron, okay? So when you see no rust means the rusting was prevented. How to prevent rusting? The metal must be higher. So the metal Y should be above here. Am I right? Very good. So now these two got rusting. If you got rusting means what? They must be lower than iron, right? The lower you are, the more you speed up the rusting. So who speed up the most? Metal X. So metal X should be at the bottom. Metal Z should be here. Is it okay? The lower you are, the more you speed up the rusting, the more blue spot that you are getting. So far, so good. Okay, now many people can do this, but now a lot of students, now the problem is what? Okay, some, not to say all, some students maybe they are not that good with the proficiency of English. Okay, the English might not be so good, as in what? A lot of students, not say a lot, some students, they're not so good with the concept of ascending or descending. Descend, go down. Descend, go down. So who go down? Why? Do they put iron inside? No, the answer don't have iron. Don't go. Iron got, sorry. Y, iron, then X, Z, and X. So the answer is A. Let me know in the chat box. Are you okay with this? Okay. So not very hard. So this is a very good question. Not very, very hard actually. Okay. So make sure so you apply all the knowledge that we learned, then should be fine. Okay, one more thing. Okay, one more thing here. This is a Selangor trial exam paper in the year of 2021. SPM, sorry, not SPM, trial exam paper 2021. Selangor. Okay, Selangor have two sets of paper. Selangor have set 1 and set 2. Okay, because they scared the leak question. Selangor and Perak normally have 2 sets of paper. That's why some school in Selangor, they have set 1, some school have set 2, different one. Okay, so anyway, let's look at it. This is the experiment for rusting because you have iron nail. Iron nail go with metal X, you see pink spot, no rusting. Iron nail with blue spot, got rusting. So easy, understand? So same thing, in this question, they want me to go for electropositivity, but the only difference is what? In this question, what they want? Ascending. All good. So no worry, we still do the same thing. So this is iron. So when you see pink spot, when you don't see any blue color, means no rusting. No rusting means that this metal X prevented rusting. How to prevent rusting? Higher. Okay. So next one. This one got blue spot, got rusting. How to make sure there's a rusting? This is iron. If you want to have rusting, this metal must be lower, metal 1. Okay. Yeah, simple as that. So what they want here in this question, they are looking for ascending. Ascending means climb up, going upward. So go up. Y, iron, and X. So Y, iron, and X. The answer is B. Yeah. So not hard. If you can do the question just now, it's almost impossible you can do this question. They are same type. Yeah, they are very similar. They are quite similar. Okay, we are done with this. Okay, next one. Okay, next one. All right, the next question is another way they ask the question, not to say very hard. It's quite easy as well. Just another way of asking. So you can see here, this question coming from Malacca 2021 trial exam paper. So you have 4 test tube, 1, 2, 3, 4. So the question asks, after 1 day, which test tube turn blue? Okay, so guys, what is the intention? When a test tube turn blue means what? Which one? Rusted. Which one rusted? Understand? Which one rusted? Simple as that. So let's look at the first one. Aluminium and iron. Aluminium higher than iron in ECS, prevent rusting. Zinc and iron. Zinc higher than iron, prevent rusting. Magnesium and iron. Magnesium higher, prevent rusting. This one, iron and lead. Look at ECS. Lead is lower than iron, speed up rusting. So when there is rusting, there is blue color. If you really understand, you guys will love to do rusting one. At least for me, rusting is easy than electrolysis now. Okay, I think electrolysis is so much complicated. Rusting very straightforward only. Yeah, so if you really understand, you shouldn't have a big issue for rusting. Okay, the last question for tonight. Okay, the last question for tonight is a subjective question. Okay, this is a 3-mark question. How to do it? Last question for tonight. You are given a table. Same thing is a rusting thing. And again, you notice that this experiment don't have phenolphthalein. That's what I told you all. Phenolphthalein not really important. Phenolphthalein is optional. Optional means what? You put, you don't put, never mind. Okay. All right. So now what happens? Same thing. Iron go with copper. Blue spot is present. Make sense lah? Copper lower than iron in ECS. Speed up rusting. So when there is rusting, blue spot. Zinc and iron. Zinc is higher than iron. Zinc prevent the rusting. So when no rusting, no blue color. See that? Okay, now we understand the concept, but you need to know what to write, because sometimes you understand is only one part. You understand, but you don't know how to write. No point. So we must know how to write it. So the question asks us to explain the differences of the observation in the test tube for both experiment. Total 3 marks. So let me show you how I do it. So I will do this. I will do this. So I'll write like this. Okay. So in experiment number 1. Okay. Iron. Okay. I'm lazy. I write symbol. Iron. it's more electropositive than copper. So when iron is more electropositive, so what? Iron will lose electron, right? The more electropositive you are, the more keen to lose electrons. So iron will actually lose electrons. So iron atom loses electron or 2 electrons to form Fe2 plus ion. Okay, so the presence of Fe2 plus ion detected by potassium hexacyanophosphatate 2R, potassium hexacyanophosphatate 3 solution, and show blue spot. That's it, but not done yet. I only explain what happened to the first experiment. Is okay? So second experiment is easier. Okay, so in experiment number 2, what happened? You have iron and zinc. So iron and zinc, what happened? So zinc is more electropositive. Zinc is more electropositive than iron. So when zinc is more electropositive, means what? Zinc will lose electron. So the zinc atom will actually loses 2 electrons, to form Zn2 plus ion. So when you form Zn2 plus ion, so what? So there is no Fe2 plus ion is present, or you can say Fe2 plus ion is absent. So when there is no Fe2 plus ion, so that's why you don't see blue color, no blue spot. Sorry, my bad. Is it okay? That's how you do it. The answer looks lengthy, but it's not hard to write. Actually, I just try my level best to explain as detailed as possible. Simple as that. Okay, so I hope all of you have a good idea on rusting concept as well as corrosion. It's not very complicated actually. Yeah, so very simple. You see blue color means got rusting. Why got rusting? Got Fe2 plus. Okay, so when you don't see blue color means no rusting. Simple as that. Okay, when you understand this concept, it's not too hard actually. So yeah, with that being said, we are all done with the very, very long Form 5, Chapter 1, all finished already. So by next lesson, we will kickstart with a whole new chapter, Form 5, Chapter 2, Carbon Compound. Okay, so I think that's all for today. I'll see you in the next lesson.
So